Hi guys, in today's video we're going to look at infrared radiation and molecules, infrared spectra, how to identify functional groups, looking at the functional groups of alcohols, ketones and aldehydes, and carboxylic acids, and finally we'll look at an exam style question.
Well, all molecules absorb IR radiation, and IR stands for infrared. Infrared wavelengths are part of the electromagnetic spectrum. So our covalent bonds will absorb the energy from these wavelengths, cause them to vibrate. And they can vibrate in two different ways. They can stretch, vibrating from side to side, or they can actually bend, vibrating like this. Now, the amount of vibration depends on three main factors, and these are bond strength, bond length, and the mass of each atom. And the absorbed energies can be displayed as an infrared spectrum or an IR spectra, which we'll have a look at now. So in our IR spectra, most bonds will vibrate at a frequency between 300 and 4,000. And the absorbed energies shown in this spectra are produced as follows. Our IR beam is passed through our sample. Now some frequencies will be absorbed, but some will emerge through the other side. And we analyse this emerging beam, allowing us to produce a graph of transmittance versus frequency of the wavelength. So we produce something that will look a little bit like this, and you can see we have transmittance here on the y-axis and wavelength here on the x-axis. So it looks kind of like an upside down mountain, and each different peak corresponds to a different functional group, and that allows us to identify functional groups. So how do we know which peak represents which functional group? Well, the data for this is actually found in our data books, but it's very useful to be able to look at an IR spectra and to immediately recognise or to have a kind of inkling of what functional group you're looking at. So in today's video, we're going to have a look at some of the most common functional groups and how to identify them. So we have our carbonyl group, our C double bond O, and this is in aldehydes, ketones and carboxylic acids, and that appears between about 1,640 and 1,750. Now, the same functional group can actually appear in two different compounds. We know that. We know we have an OH in carboxylic acids and in alcohols, and they won't appear in the same wavelength. They'll appear as two slightly different shapes in two slightly different locations. So our OH and our carboxylic acid appears between 2,500 and 3,300, and it's a very broad peak.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, click the button. Join me today and together let's make A-level chemistry a walk in the park.